Tonight's video is section 3.4, part 2, concavity and points of inflection. Your homework for this is 11 through 26. We'll be doing this tomorrow in class on the board Tuesday. It will be due Thursday. So let's look at our test for concavity on our function f. In fact, let's look at what concavity is first. Again, this is on my f function. So concave upward, so it can be like this, or here's the whole thing. So it can be in pieces. So it can have a positive slope or a negative slope, or this is all concave up. Here's concave down. So again, this can have positive slope, this can have negative slope, but they're both concavity, it's downward. So let's look at the test for concavity. Now we're at our second derivative. If our second derivative is positive, greater than 0, on some interval, then the graph of f, our original function, concaves upward on that same interval. If on my second derivative it is negative or less than 0 on some interval, then the graph of f concaves downward on that interval. Points of inflection on f. So I'm looking for a point of inflection on f, just like I just got done looking for concavity on f. For that concavity, I went to the second derivative. Let's look at what a point of inflection is. So this is my original f function. So this is f. And so there is a point of inflection. A point on f where the graph changes concavity from concave up to concave down. From concave down to concave up. The moment it changes concavity is a point of inflection. So for example, if I do something like this, points of concavity would be here, and here, and here. This is downward, this is upward, this is downward. So now that we know what a point of inflection is, let's continue. It says the point C, again, f of c, on my original function, is a point of inflection on f, since the concavity changes from upward. Okay, what was upward? When my second derivative is positive. When it changes from upward to downward. What is downward? When my second derivative is negative in those intervals. On f double prime, when it changes upward to downward on f double prime, at x equals c, or vice versa, from downward to upward. Once you know you have a point of inflection on f, then either the second derivative on that point of inflection, it equals 0, or that second derivative does not even exist at x equals c. Somehow that's what's going to happen on my point of inflection. It's either going to not exist or it's going to be equal to 0. So I'm going to use this in order to find my points of inflection. I'm going to work backwards. So let's just look at a problem. And here's what your homework directions are going to look like. Find points of inflection and discuss concavity on my function f. On this function f. I want to find the points of inflection and I want to discuss the concavity on it. And we're not going to draw it out. We're going to use calculus. So first thing I'm going to do is take the first derivative. Then I'm going to take the second derivative. Then what I'm going to do is I'm going to go ahead and use this idea that my points of inflection, I'm going to find that from setting it equal to 0 or where it does not exist. Well, there is no x's where it's going to make it not exist, so I'm going to go ahead and set it equal to 0. Factor. You guys need to stop moving negative 24x to the other side to solve. This is a quadratic or a polynomial. You factor it. Set them all equal to 0. So I get x equals 0 and x equals 2. I might accidentally say these are critical numbers, but I don't want to call them critical numbers. We find critical numbers on the first derivative. So now, please notice I am sketching out a second derivative line, okay, my x-axis, with 0 and 2, and I have my 3 test points. And remember what it said, that where I'm going to have concavity being upward or downward based on intervals on f double prime that were either positive or negative. So I need to evaluate my test points, these 3 test points on f double prime. So I chose -1, I got a positive value. I chose +1, I got a negative value. I chose 3 as a test value, I got a positive value. Now I can go ahead and find my points in inflection and discuss concavity. So since I'm going to go ahead and discuss concavity first. Since f double prime is greater than 0, where? What interval? Well, right here, from -infinity to 0. Then what? Then f concaves upward on that interval. Well, since f double prime is less than 0 or negative, where? On this interval from 0 to 2. Well, what about that? Then f concaves downward. F concaves downward on this same interval on f. Since f double prime is positive, where? On what interval? From 2 to infinity, then f concaves upward from 2 to positive infinity. Now let's talk about those points of inflection. Here's the first one. I kind of want to show this and this at the same time. It says that 0, 0, and all I did was put this 0 into the original function, and it spit out a 0. So 0, 0 is a point of inflection where on f, since what? Since the concavity changes from upward to downward on f double prime at x equals 0. Because it changes concavity from upward to downward, then x equals 0, or the ordered pair 0, 0 on f, is a point of inflection. I'm not done. We'll go ahead and scoop these together. And that's where I evaluated it. So I evaluated the 2. Now, the order pair 2, -16, where is that? On f, is a point of inflection since the concavity changes from what? From downward to upward on f double prime at x equals 2. Thank you.